Welcome back. Today we're going to go over motion graphs. In my last video, I talked about the relationship between position, velocity, and acceleration. Today we're going to expand on that theory and try to visualize it and use it on practical problems. So, first things first is let's look over here on the left at this image right here. We're going to start with the position versus time graph. So this top one right here. So the position versus time graph just tells us what where we are moving to, where our object is moving over time. So for example, at time 0, we are at 0 meters. And then we keep moving, moving, and moving, and moving up until about 15 seconds. So from 0 to 15 seconds, we went to about 140 meters. And then after 15 seconds, we continue moving, but we are moving backwards now. So from 140-ish meters to about 40 meters in 15 seconds. So one thing to note is this is not our displacement, right? It's not that we go up here and then we continue going somewhere else. This just says we are going one way, and then at this point we are going a different way over a different amount of time. So our total displacement would be just from 0 to 40 meters. But that is not what position time graph shows. It shows us where we are at what time. Now let's go to the velocity graph, which is this second graph here, velocity time graph. So the velocity time graph is the graph of the slope, the change in slope of position. So let's look at it. For example, from here to about here, you can see we are positive slope. Our velocity is increasing. What that means is from in our position graph from here to this line, this inflection point, you can see there's a little bit of a curvature. Our slope is constantly increasing. That means our velocity is changing over time. So our velocity is getting bigger. In this point right here, we have a flat section, which means in our position, we have a linear part. So our velocity is not changing. We are just moving at the same constant speed right here. So that means our flat part of our velocity is constant. And then this long negative velocity part just means our velocity is we're slowing down, 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 and then we are continuing going into the negative direction. That's what this means. This point right here at 15 where it says 0, that means there is zero slope, there is zero velocity, zero slope of our position graph right here. So there is no slope. So at 15 seconds, when we are about 140 meters, we are not moving. There is no velocity for that split second. And that's what this shows right here. And then again, we're increasing here once our velocity picks back up. So our velocity is just the graph of the slope of our position. Similarly to velocity, we have our acceleration versus time graph. Our acceleration just shows how much we are accelerating over time. And this is the same thing as the slope of our velocity. So in this section, we have a constant slope, which means this is linear, right? So we're going from 0 to about 15 meters per second at a constant rate. Our slope is the same, so our slope is the same here. Whenever there's a constant, that means velocity is the same. We are not accelerating, so we're at 0, right? Acceleration is on the 0 line, and so on and so forth. So again, position over time tells us where we are over a certain period of time, not our displacement. Our velocity shows us the change in position over time, and then acceleration is change in velocity over time. So the slope of our position, this just equals to the velocity, and slope of our velocity is the acceleration. All right. So another thing to note is our displacement down here. So displacement is the area under the velocity curve. what that looks like is we're just going to look at this portion right here, right? So from about 4 seconds to 6 seconds, so we're going to say this is about 2 seconds, we are at 15 meters per second. So our area under this section would be 2 times 15, so 30. So our total displacement would be 30 meters, um, right? Because this is 30 meters per second. So it would be, or sorry, it'd be 15 meters per second times 2 seconds. Our seconds would cancel out. We would just be left with 30 meters. So that is why we use the velocity curve, is so that these seconds can cancel out, leaving us with a displacement. So again, the area under the velocity curve is our displacement, while the curvature of the position time graph is just where we are located at a certain time. All right, let's move on. So let's get into some general rules for each of these graphs. So for the position versus time graph, our slope of this graph is velocity, which should make sense because that's what this whole premise is on. If we have a flat line on the graph, so a flat line, this means that there is no movement. No movement. So if I had position versus time and I was moving, and then I stopped here, there is no movement in this section. And then third rule is if we have a curved line, this means our velocity is changing. Right? So if I was to take this and say, kind of give it a curve like this, so this is your position versus time graph, our velocity is changing and it's increasing as it goes up. Similarly, if it was like this, our velocity would be changing and our velocity would be getting closer and closer to zero. So that's all that means. If our velocity was a straight line, like this, that means this is constant velocity, right? So I'm going to add a fourth note here. Straight slope is constant velocity. All right, and that's everything for position and time graph. Now let's moving on to velocity versus time. So the slope of our velocity graph, this is our acceleration. If we have a flat line, so flat line on our velocity time graph, this means we have constant velocity. So what was a straight slope up here is equivalent to a flat line down here. And then finally, area under curve. This is equal to our displacement, as stated above. And we'll get into some practice problems in just a second. And finally, for acceleration versus time graph, the area under this curve, this is equal to our change in velocity. And that's it. So if you want, go ahead. I would suggest writing these down, get these kind of engraved in your head. This is everything you need to know when it comes to reading and kind of drawing out these motion graphs. All right, let's go ahead and move on into an example problem. So we're going to do this one together. So we have a motion graph right here. As we can see, this is v of t over t. So this is velocity time graph. And it's asking us what is the displacement of this motion graph. So recall that displacement is the area under velocity curve. So let's go ahead and find the area of this graph. So we have 1, 2, 3, 4, 5. 1, 2, 3, 4. So our area would just be our length times width. So it'd be length times width. Our length is equal to 4. Width is equal to 5. So our area slash displacement is equal to 20 meters. And there you go. And it's meters. It could be any unit, but usually whatever unit is given to you. But this is one of the easiest motion graphs because it's just a constant straight line. But that is the general premise of finding displacement. So let's do a quick pause problem. So a pause problem, if you're new, just means try to do this question on your own and then go ahead, pause the video. After the video, we'll work through it together. All right, hopefully you had some time to look through this. So as we can see, this is another velocity time graph, and we're asking for the displacement. So we can see the velocity starts at 0 meters per second, and it increases linearly to about 2, 3, 4, 5, 6, 10 meters per second in 5 seconds. So displacement again is the area. However, this time our area is a triangle. So area of a triangle is just 1/2 base times height. So this would be 1/2. Our base is 5 and our height is 10. And this just equals, so our displacement is equal to 25 meters. And there you go. That is the final answer. So at any time velocity is changing linearly, you'll get a triangle. And yeah. All right, let's move on to our third example problem. So it's a slightly harder multi-conceptual problem. So we have a position time graph here, and we want to know, is the velocity increasing or decreasing? And is the acceleration positive or negative? So we're just going to talk this through together. We don't need to solve or anything. So first one's first, is velocity increasing or decreasing? Remember, velocity is the slope of the position graph. So this is the position time graph, and we can see our at every single point, So our velocity is the slope here, slope here, slope here. And as we are going further and further, our slope is it's increasing, it's getting bigger. So the answer is our velocity is increasing. Now, for acceleration, is it positive or negative? Remember that acceleration is the change in velocity, and because our velocity is increasing, right? It is our the slope is getting bigger and bigger. That means our acceleration is positive. So again, another way you can look at this is if the position starts moving slowly and then automatically it goes really, really quickly in a short amount of time, like this. So it's slow and then shoots up kind of like this. You can kind of tell that both velocity is increasing and acceleration is positive. So I suggest you guys do some more practice problems on other curved motion graphs, but that is the general concept. Let's look at some common mistakes for motion graphs. The three most common is people assume that the height of the graph is velocity. That is not the case. For instance, here, right, once this was increasing upwards, people were like, oh, this must be your velocity. It's not. Velocity is the slope. Don't forget your slope or the change in slope. So the slope of position is velocity, slope of velocity is acceleration. The change in slope of position is acceleration. And don't mix up area under the curve with your slopes. So don't mix up your displacement versus position and distance traveled. All right. And so that is essentially the general gist of motion graphs. I hope that helps. Remember the general rules going from position, velocity, acceleration. If you understand motion graphs now, uh, you are in a great position. The next video I'm going to make is on projectile motion. So please check that out. If you are still having trouble with acceleration, velocity, position, check out my previous video where I dive deep into those concepts. And yeah, I'll see you next time.